Hey guys, like most teachers in the country, it was a little weird to try to put together resources for our immediate lockdown. And so, what we were asked to do for Lynchburg City Schools is put together a 5-page packet, 5 sheets with stuff front and back for each subject, and just kind of send them out so that there was something that people could do to review stuff that we'd already covered. And so the purpose of this packet was not to teach you new things, but to give you a good overview of the things we've learned in Algebra 2. So I wanted to walk through some of the stuff with you. First, there is a page that goes through like a table of contents, a list of topics, and it says right at the top that what you should do is you should use Google or use Khan Academy in order to search these topics. If you just search any one of these, like basic rules of exponents, what you're going to get is you're going to get a video from Khan Academy that's going to do a pretty good job and also have some topics there. Khan Academy is not perfect. It is not the most exciting videos. Not that I'm throwing shade as someone who makes the most exciting videos in the world, but just know that those are available for every one of these topics in this packet. The other thing I want you to notice here, it says use Wolfram Alpha. Wolfram Alpha is a little bit more powerful than Desmos. It does allow you to see more detailed answers. So it says if you want to see step-by-step answers for some types of these problems, they will actually work them out for you. Whereas Desmos might just give you a decimal answer, Wolfram Alpha will give you an exact answer as a mathematician would do it. So that's a big hint there for you on that tool. So today on this first video, what I wanted to do is just take a look at some of the first few sections, specifically exponents. And so when we look at exponent rules, the first one is when we're dealing with exponents, remember that when we have an expression with an exponent raised to an exponent, then we're going to multiply those together, because this is the same as writing -2 times -2 times -2, and each one of them, since the squared is on the inside, is squared. But we still write it 3 times. And the next thing you're going to notice is that we can kind of collapse all those together. This is really to say, if we're going to multiply 3 things together, then we add the exponents. So it's -2 to the 6th power. Now, there's a bit of a catch on this one. It's that it's not -2 squared, but it's -2 squared. -2 squared is not the same as -2 squared. And so when we do this, we actually have the 2 to the 6th and then the -1 to the 3rd. I know I started off with kind of a tough one here. I'm Mr. Volk, and since I do math every day for fun and for a living, this stuff doesn't scare me. If you're scared right now, I want you to calm down. It'll be okay. This is just a video. If you need to cry, just pause it so that you can cry in peace. When you feel like you're up to it again, press play again. 1 to the 3rd, -1 to the 3rd is just -1, and 2 to the 6th is, 2 to the 6th. It says simplify, so we're going to go ahead and put it as -2 sixths, but technically we could go ahead and raise 2 to the 6th power. And that, you could use a handheld calculator if you wanted, but that's 2 times 2 times 2 times 2 times 2 times 2, or simply -64. The second one, I want you to notice we have a negative exponent. What negative exponents do is they flip the fraction upside down. So this is the same as saying -5/2 to the 2nd. The next thing we're going to do is we're going to distribute that and square the top and square the bottom. So that's the same as saying -5 squared over 2 squared. And then when we do that, we end up with -25/4, which is about as simplified as it gets. I'm going to put the negative kind of in front, and that's going to be our answer for number 2 there. Number 3 has a negative. So what about if it's not a fraction? How do we deal with the fact that we have a negative? Well, we go ahead and make it a fraction. So we're going to go ahead and flip it upside down, and then we're going to distribute that 3 to each thing. So if I do that, I end up with 1 over 3 to the third, x to the sixth, and y to the third. And you go, why isn't it a negative 3 and a negative 6? Well, because I got rid of the negative when I flipped it upside down. When you flip it upside down, then it accounts for the negative. Now, the only thing we can do to kind of simplify that is the 3 to the third. 3 times 3 is 9, times 3 is 27, so we end up with 27 x to the sixth, y to the third, and over top we have just the 1. I'm going to make that a little bit bolder. Number four, we have negative exponents. And so each thing that has a negative exponent on it is going to flip. But the 5 does not have a negative 2 on it. The negative 2 as an exponent is on the x, but not on the 5. So what we're going to do is we're going to keep the 5 where it is, and we're going to flip the x to the negative 2 to the top, and we're going to put the y to the negative 4 to the bottom. So it becomes x squared over 5 y to the fourth. And that's it. Number 5, again, we're going to look at what has the negative on it. I made it too big. We're going to look at what has the negative on it, which is just this y to the negative 2. And then we have an x to the negative 1. But I want you to notice we also have other x's and y's. So first thing I'm going to do is I'm going to put those on the top and bottom like they'd fit. So by switching these up and down, I end up with y, that was already there, plus the y squared. Actually, it's multiplied. Remember, when we have these two things right next to each other, we're multiplied. And then we have x times x to the 1. We can combine these because y times y squared is y to the third. And x times x to the 1 is really saying x to the 1 times x to the 1, which is x squared. Number 6. Number 6 looks really complicated. But again, if we just focus on one thing at a time. So what I'm going to focus on, the first thing I'm going to focus on is just the numbers in front. So I'm going to highlight these in pink. I'm going to highlight that 3 and that 2, that negative 7, and that 42. I'm going to ignore the exponents and the variables. If I think about the problem just right there, and I say, okay, 3 over 2 can't be simplified, but negative 7 over 42 can be simplified, I could say that this is like saying 3 over 2 times negative 1/6. Do you see how negative 7 over 42, I can take a 7 out of both of those. And so I've made that easier. So I'm only focusing on the pink part, and I'm going to keep going on this. Only focusing on the pink part, I end up with negative 3 over 12. Now, negative 3 over 12 can be simplified. It ends up being negative 1/4 because I can take a 3 out of the top and bottom. And if I was just talking about the pink part, I am perfectly finished right there. Now, let's talk about the x's. So I have an x to the 5th here, and I have an x on the top there. Since when we multiply exponents, we multiply straight across, what I'm going to do is I'm going to multiply them straight across, and that's going to turn this into x over x to the 5th. So, again, I'm only focusing on the blues, just the x part. And when I look at the x's, I have one x on the top and an x to the 5th on the bottom. I can cancel something out on the top and bottom. I can cancel an x out on the top and bottom. Now, before you say, well, if I cancel out an x, is it 1/5? No. If I cancel out one x on the top, I still have x to the 4th on the bottom. I have no x's left on the top. So what I'm going to do is I'm going to put a 1. Just like if I had a 7 over 42, I could cancel out the 7 on top, and it'd be a 1 over 6. All right, at this point now, we have finished with the x part. I want to do one last section, which is the y's. We've got y's in 3 places. So as we put this together, we're going to say y to the 9th times y over y to the negative 2. And we did mention that y to the negative 2, when we have that negative exponent, it's going to be the same as if we flip forward. Sorry, I'm jumping over the place. Same as if we flip forward. So I'm going to go ahead and put that on top. And that's going to give me y to the 9th times y squared. That's a G. My handwriting's really bad. I've been teaching my daughters these last few weeks because we're homeschooling them, as everybody is homeschooled now. And my daughters have a hard time reading my handwriting as I'm trying to teach them handwriting. It's really bad. I'm going to put a 1 here on this y because it didn't have one there, but it's obviously at least one y. Now, if I'm going to combine all those, all I have to do is add the exponents. And so I go y to the 12th. And so I've finished my 3 parts of this problem. So to put it all together, what we're going to do is just write all 3 parts in one fraction. On the top, I have 1, negative 1, 1, negative 1, and y 12th. So I'm going to say negative y to the 12th. On the bottom, I have 4 and x to the 4th. And so that ends up being my answer to all of them. So we actually solved each one of them separately. Each piece ended up being its own little simpler problem. None of the problems were that complicated, but as we got going, then we were able to put them all together. So those are our basic exponents. If we talk about fractional exponents, this is sometimes the most scary thing to people because they forget that this is something they've done before. So what we're going to do is we're going to first talk about the fact that fractional exponents, x to the 1/2 is like writing the square root of x. And x to the 2/3 would be the number on top stays an exponent, and the number on bottom tells us what the index of a root would be. So this one's a square root right here because the 2 is invisible, but there is a square root there. And if it had a 3 on the bottom, it'd be a cube root. So when we take a look at number 1 on this problem, we end up with 8 squared and then the cube root of it. Now, as we evaluate these, it says evaluate them without using a calculator. So we could definitely do 8 squared in cube root, but we could also do cube root 8 and then square it. And the reason we're going to do that, because that actually makes our number smaller. The cube root of 8 is 2, right? So then it's just 2 squared, so 4. So just to summarize this real quick, what we started with was 8 to the 2/3 power. And what we ended up with was 4. So why did 8 to the 2/3? Well, a few giveaways. 2/3 is less than 1, so I know it's going to get smaller. So that's kind of a good check as we get going. For example, if I look at the next one, and I see that negative 1/2, that means it's probably going to get smaller, right? So let's take a look. The first thing we're going to do is we're going to deal with the fact that 4 has a negative exponent. Or do you want to deal with the fact that it's a square root? What's easier, doing a negative exponent or square rooting 4? Well, a lot of you would probably say square rooting 4 is a lot easier. So we're going to say square root of 4 to the negative 1. The square root of 4 is just 2 to the negative 1. And we have to think for a second because it can be overwhelming, but if we think for just a second, we say, well, what does a negative exponent do? It flips the fraction upside down. So instead of being 2, it's 1 over 2. Another example of this would be is if I had a number like 6 to the negative 2. That would be equal to 1 over 36. So that's just a little scratch work to show you another example. Let's take a look at number 3. Number 3 has already kind of broken it down for us. It says, what if we took the 4th root of 16? And at first you might go, oh, but I'm really bad at 4th roots. because I don't memorize all my fourth roots. What do I need to multiply by itself 4 times to get 16? It is just 2, but even if that scared you, you could break this down in any number of pieces you want. So, for example, we could say, instead of just saying fourth root of 16, we could say the square root of 16, and then the square root of that, and then square it. Okay, so notice that I turned the fourth root into 2 square roots. Now that's a bit fancy for you, but if we do that, we'll notice that the square root of 16 is 4, and then we'd have the square root of 4 is 2, and then we square that and we end back at 4. One way you could do that is you could say, well, should it be getting smaller or bigger? Well, we're doing more rooting. In other words, we have a bigger number on our denominator of our exponent, so we end up getting smaller. And I like 4 is the answer for that one. Number 4 is the cube root of 1,000 squared. Now, I'm going to switch this order because the way it wants me to do it, it's telling me, it says, hey, do the squaring first, but I'm going to swap it out. So this is the same as if I said the cube root of 1,000 and then squared it. Why would I do that? Because the cube root of 1,000 is just 10. And then I can just square that to get 100 as my answer. Number 5 has a bunch of stuff going on. We'll start with the cube root of negative 27. I don't think that's too scary. The cube root of a negative is possible. If it was the square root of a negative, it would be imaginary. But the cube root of a negative 27 is just negative 3. I still have to put it to the negative 4. So does that mean the negative and the negative cancel out? No, that's not what that does. Remember that a negative just flips it upside down. So we end up with 1 over negative 3 to the 4th. And if we take that one step further, we're going to go ahead and say 3 times 3 times 3 times 3. And the negatives are going to cancel out because that's an even exponent. And we end up with 1 over 81. Last one for today. We have negative 25 to the negative 3/2 power. And we've got some parentheses going on. So first I'm going to just kind of remind each other that this negative stays negative. It's going to kind of tack on at the end because it's outside those parentheses. Everything else, though, we can kind of work with. I'm going to do the square root first. So if I do that, then we say it's negative square root of 25 to the negative 3rd. So I took that 2 in the denominator and made it the square root because I know that what the square root of 25 is. The square root of 25 is just 5. Then I'm going to flip it upside down and I'm going to cube it. So I end up with negative 1 over 5 cubed, or negative 1 over 125. This packet might have been overwhelming to you. Maybe it's not. Maybe it was just overwhelming because you're not used to having to do this type of math without a calculator. You could have easily typed them in. Obviously, the calculator could have handled giving us 100 on number 4 without even thinking. But also, then you wouldn't have to think. So I want to be back in communications with you guys a little bit. So we've done so far just the first 2. Okay. And what I want to do is I want to be able to post videos for you and stay as your math teacher for a little while longer.